Hi, this is Frances Ringwood here for Infrastructure News' CPD On Demand program. Today I'm speaking to consulting engineers and scientific firm SRK South Africa, to Peter Shepherd, who's a hydrologist, and we'll be talking about different water quality uses for different applications. So Peter, hi, thanks for joining me.
Thank you very much for having me.
Cool.
It'll be fun.
Okay, great. Let's get into the first question. Why do water users choose to use different qualities of water for different applications?
I think, water is very, very expensive to treat water. So, and in South Africa, we don't have an unlimited supply of water that we can tap into all the time. So we've got to really be able to treat the water to a quality that can be best used in the industry or in what you want to use it for. So for instance, if you have water that's in tailings, you don't want to have water that's going to corrode your pipes or something like that there. So you need to be able to take out the elements that corrode your pipe there, for instance. Or if you are in gland service water, which is the water that you use in pumps, you don't want water that's got sediment in there. So you want to be able to use water that's clear for that, but it doesn't matter what other kind of minerals are in there or elements are in there. So you really want to be able to use the water in the purposes that you need it for in these industries. It is if you always take it through to potable water standards, then you over treating the water, because then, for instance, you'll mix it again with slurry or mud to be able to take it to the tailings dam, or and then you just spend more money than you should have.
So very much in mining and industrial applications, it's almost necessary to treat to different qualities as a cost management exercise.
It's very much a cost management exercise there. But it's not only in the mining and industry. In agriculture, for instance, sometimes you only really want to take out, if you got irrigation sprays, you're more worried about your silt content so that it doesn't block up the irrigation thing. So then you would just treat it to be able to take out the silt. Okay. And so you would settle the water. Really, that's what your aim would be for treating the water of that kind of quality.
Okay, brilliant. Thanks so much. My next question is, you've sort of spoken to this already, but I think I'm going for more what municipalities do. Is it only industry and mining that can benefit from this process, or can utilities also realize financial benefits, and what kind of financial outcomes can they expect?
No, I mean, municipalities can use the water there. Polokwane, for instance, they for a long time the water from their sewage works was almost cleaned through filtrating through the sands and then was used for irrigation. Mm-hmm. Where the municipalities, I think, are using the water more and more is that it's really treated sewage water that they can use. Mm-hmm. And that really is a resource that they can use. So they, for instance, can go to a mine and say, all right, you need to use this water rather than potable water, because the quality, you're not really worried too much about the quality of the water, whereas the communities require potable water over there. So their allocation of the resource, which can be potable water as well as sewage or secondary water, they can allocate the water to different industries depending on what their best uses are.
Okay, so there can be financial returns for the municipality in two streams in that way, if I'm understanding you correctly, because they can sell lightly treated wastewater to the mines, and the mines might treat that then after it's been used through their system to a potable standard again. So that's a potential for them.
No, very much so. They sell the water to the mines. Mm-hmm. Or to industries that treated water, and often the mines and the industries help with upgrading some of the infrastructure in the sewage treatment works there. So as part of the mine or industries, they say, okay, we need to be able to get some of the water, but we'll help you by adding another component to the sewage works to treat the water.
Okay.
So it helps them with their budgeting, because now they don't have to spend the money on upgrading their sewage works there, and they're getting additional income from them, from the rest of the industries or mines.
Okay, so when mines and governments collaborate on shared infrastructure, then everybody can save money.
Yes, and the environment as well there, because now potentially there's a lot of sewage works in South Africa that are not up to standard, and if the communities and industry can work together with the municipalities, you will get a better treatment of water. You're not going to get as much environmental spillage to the natural resources. It's just a win-win for everybody.
Okay, great. And you mentioned Polokwane, but are there any other utilities that you know of that have sort of a cascading water quality or different quality reuse approach as part of their operations?
Yeah, in that area there, you've got Mokopane that also uses the water. It gets used by the mining industry there. Most of the mines, for instance, in the past, their treated water used to be discharged into the river. They reuse their own water, so they use less water from the municipalities in the potable water scheme. Then you also get in Beaufort West. They also use some of the treated water for other uses. Then also, in some of the other countries like Windhoek, they use a lot of their treated water back in their systems. So they take it right through to potable water from the sewage water, and that water again gets reused. So yeah, I think it's a real great resource that people are using compared to 15, 20 years ago. It was just thrown away. Somebody else can deal with it.
And I've seen Johannesburg Waters even advertising that they want proposals from people who want to sell or buy their wastewater. So, even the big metros seem to be finding ways to reuse.
No, I think once it cascades like that, the way they've seen it being successful in other parts of the country, it will always be used as a resource.
Okay.
I think it's very, very important to note that we in South Africa are a very, very dry country, and we don't have unlimited resources like some countries around the world there. So we have to use all our water resources as much as possible, and these help us along. Droughts help us especially. As soon as there's a drought, more people get very much involved in trying to recycle water.
Okay, thanks. And then since President Jacob Zuma released the UN report on how wastewater should be viewed as an untapped resource, which is what you were just speaking about, water professionals have started once again discussing the technology and financing arrangements which would make such a move possible. Does the technology and financing arrangements which would make such a move possible exist? Do we have it in South Africa, and do you have any financing suggestions? Because that seems to be the big question now. How would we pay for such a move?
It's been a big stumbling block there. Certainly in South Africa, we've got the technologies to be able to treat any waters to a standard that can be used elsewhere. But it is very, very expensive to take it through, say, to potable water standards, especially with the technologies that are available at the moment there. There's continual work being done to try and reduce the amount that it costs. But in general, I think within the next 10 to 15 years, there will be a financial plan to be able to sell the water at a profit. At the moment, that is not the case, but there are enough pilot studies around to be able to show that that could be the case in 10, 15 years' time. And we look forward to those days there. We've got to make seawater profitable, then we'll be fine.
Well, people seem to be fine with the idea of desalination, but I think there's still a yuck factor around wastewater reuse, which, I'm sure as an industry professional, you find a bit surprising, because when you know how the treatment works, you know that water is 100% potable, and there shouldn't really be an issue around that.
Yes, the perception is, you'd rather it comes out of the pipe straight into your sewage works, straight into your treatment works. You will always get people thinking, well, that can't be right there. But if you put it in a river and then 2 kilometers downstream, you pick it up and put it through the same treatment, then it's okay. So it's really just a perception thing, and I don't think it's easily going to be resolved. People will always have that perception. Well, we drinking sewage water.
Okay.
We all do though. If you have a look down the Vaal River, how many times the water goes into the Vaal River from sewage works and then reused elsewhere.
But it's all just chemistry, isn't it? I mean, it goes into the river, and if it's got high concentrations of nitrates and nitrites, then you need to remove that. And if it's coming directly from the wastewater treatment plant, it's the same thing, and you have a man-made process to get rid of the same.
It's all to do with perception. Perception is what drives that kind of thing. And I mean, there are some industries that they prefer not to use that water because of their brand. They don't want to be seen to be using treated sewage water.
On that point, you spoke about other countries around the world that were using direct use to turn their wastewater potable. Do you have any case studies that you can discuss there, and how they've sort of managed
the
perceptions and branding?
Yeah, I think some of the bigger companies do not. They just won't go for that kind of treatment there. They'd rather get a separate resource for that. But for potable water, that seems to be. I mean, it's Windhoek. Windhoek seem to be able to have convinced people that they can use the treated sewage water for potable water.
They're even drier than us, I think.
Yeah. It's all down to degrees of dryness. The drier you are, the less fussy you are how you get your water there.
Okay, great, thanks. And then what are some of the greatest infrastructural challenges to implementing broad-scale wastewater reuse?
Yeah. That's always an interesting one there, because in the past you used to have one pipeline. So you take the water from the Vaal Dam, you have one kind of source of water, you have a reticulation of that water around Johannesburg, for instance, and that water is potable water. So, for instance, if you wanted to water your garden, you're using potable water to water your garden. And if you now decide, okay, we're going to try and use this treated sewage water for gardening purposes, there you have to have a whole new reticulation network of pipelines to be able to distribute that water there, and that is very expensive. You're kind of doubling up your infrastructure for that there. But if you take it slowly and you start with industry, and then you have offtake lines that go to residential areas, you eventually will get it right there.
Okay, so you start with industry. That's
that's where the bulk users. Yeah.
Make your biggest gains the fastest. Okay, thanks very much. And then how can engineering professionals address the stigma attached to direct wastewater reuse? So community engagement, or what sort of programs can they put into place? Yeah,
it's those are more going to be resolved by the softer issues. I don't think engineers will just say that's the quality of the water. But the more social scientist kind of route there, those are the people that will be able to convince communities and such like people that the water that they're getting is of a good enough quality and meets their requirements, and you won't get sick from it there.
So you might need an interdisciplinary approach if you want to really make it work at a national level.
Yes, very much so. And I guess that's part of what SRK is, the one kind of stop shop where we can take it from the social sciences all the way through to designing thing there.
Have you got social scientists in-house?
Oh, we got lots of them now.
Okay, brilliant, thanks. And have you worked on any projects for industry or mines where your client opted for using different water qualities for different site applications?
No, yes, very much so. Sorry, no, yes. I'm talking. No, very much so there, and I think the biggest uses were the biggest areas that you can do that kind of work has revolved around the use of. There were three kind of uses in the area. One was potable water, which reticulated around the whole site at one stage, like I was explaining to you, and then there was but there were very few potable areas that just needed potable water. So the infrastructure that was done was to take that whole potable water reticulation system and convert it to a processed water system. So that could be the secondary water or the less treated water, and then a new reticulation for potable water was implemented separately, and that was quite successful there. Because
sorry, Peter, can I just ask, what was the commodity that you were doing the treatment
platinum.
system for? Platinum.
Yeah.
Okay.
So, and that was really because we were running out of water in the area there, and there needed to be clever ways to be able to utilize the available resources there, and that was a very successful way. Convert it to infrastructure and use the water where you needed to.
So it made the mine sustainable where it might otherwise not have been, and also, I mean, in the current economic conditions, mines, I'm sure, are looking for ways to manage their costs, manage their water costs.
Yeah, well, you know, with most mines, if you don't have water, you don't have a mine.
Mm.
So that was the kind of attitude. Let's try and release as much water to the town as possible, so that first of all the town had sufficient water, and then the excess the mines were using less water, substantially less water there than what they did before.
So you've been in SRK has had an instrumental role in one of these collaborative water reuse projects.
Very much so, yeah.
Okay. And how do nearby communities benefit when companies use different water qualities on site?
The easy one is that the water that would have been used by the mines is now no longer being used by the mines, so that water can be used for other communities and the surrounding areas there. But I think there's the other one now where there isn't any municipal related infrastructure around. So there's no pipes or something going to a town or village. The mines can help with developing water supply schemes for those villages by using, for instance, the groundwater, which they may have used in their process. Now they're not using it because they're using treated sewage water. So that groundwater resource can be used to supply communities.
Okay, I think that's part of one of the. It's either the NDP or the Presidential Infrastructure Plan, isn't it, for industries to develop the infrastructure for mining communities
around it, and it's the right way to do it. If you think about it, you can't, as a mine, take all the water and then you get people that don't have any water living around you. Everything nowadays, I think, must involve the community surrounding a mine or an industry or town. Everybody has to be able to look after each other there. There's no, you can't just hold it to yourself and say, no, you can't have any of the water. No, those days are gone.
And I think that sort of community engagement is part of the environmental impact assessments, which SRK is also instrumental in doing.
Yes, very much so. I mean, that right from the early years I've been here for 25 odd years, and there have been many projects right from the beginning where we started with the environmental kind of work to look at sharing communities, sharing water with communities.
Okay. Thanks. And how does this type of planning meet projected water availability scenarios as illustrated by climate change projection models for South Africa?
Yeah, it's climate change. The thing that with climate change is there's some easy design aspects with regards to dealing with. I think the flooding part is the easy part, but the climate change side that is more of a problem is going to be on the supply of water there. And you're going to, for instance, on your surface water resources, in some areas you're going to have less water available for planning. So planning is much more of an important aspect now with regards to allocating water to various municipalities, and I think we're still grappling with how to best implement some of these things as hydrologists now, and what is the solutions to it. We know it's going to happen, but how do we resolve it? It's going to be or deal with it. It's going to be what will happen in the next 5-10 years.
Okay, moving on to water balance. What are the main areas where water is used in different industries like mining, for example, and steel?
Okay, yeah. Water balances, for me, are the most exciting things in the world there. Because you really need, then the reason why you do water balance is you want to understand where the water comes from, where you're losing your water, and then you use that to help with your planning on how you can best resolve some of the water related problems there. What a water balance is that you will get water that comes into a mine, the water that gets used within a mine or an industry itself there, and then the water that you lose from the mine there. So it has many uses in managing water on a mine itself there. The first ones would be you want to understand how much water you need to sustain your operation, and then the second ones will be how much water are you losing, and is there an opportunity to reduce what you use there. That will then assist with your water demand so that you can reduce the amount of water that you bring into the system there. So in a mining kind of environment, your biggest water losers is always the tailings dam and residue deposits there. That you lose your water, because on a tailings dam, for instance, you're getting a lot of water that's lost to evaporation, because what you're doing is you're transporting mud and you're depositing on a dam, and that mud then is spread around the top of a tailings dam. The water then evaporates. So that is maybe one of the largest components of water losses. The second one is that there's water that's contained within the tailings dam itself there, and that's called interstitial storage of water, and that water is just held in there in between the granules of mud, and kind of just stays within the tailings dam itself, so you can't really reuse the water. And then the other one is seepage. So if you need to look at ways to try and reduce your water usage on the tailings dam, for instance, you will look at trying to reduce your evaporation. In order to reduce your evaporation, you must either pump less water onto a dam itself, or you must concentrate it on to have a smaller area for it to evaporate from itself. If you look at seepage has been a major kind of concern of tailings dams, because the pollution plume gets into reservoirs, into neighboring boreholes, that kind of thing, and there's been more and more emphasis on trying to reduce seepage. So that can be done by either lining. So lining of dams now is quite popular at the moment there, especially with regards to some of the pollution control dams. Most of them are lined now, whereas 10-15 years ago they weren't lined there. So that will reduce your amount of seepage that you have from the system there, and so that is an area that is well understood now to try and reduce it. But the area that I believe that there's going to be large amount of progress going forward is evaporation, because evaporation and interstitial storage are around about 60% of the water losses, 60-70% of the water losses from a mine. So if you can reduce that, that would be your best kind of way of reducing your water demand itself. So that helps really in the tailings environment, in the industrial environment, and you lose a lot more to evaporation, sometimes in the actually industry itself there, but they also have dumps and areas that you can perhaps reduce your amount of water you're putting onto these dams there.
And some mines even have evaporators, don't they? So
yes, it's something we as hydrologists should not even consider in South Africa. Those evaporators are used extensively in more rainy areas there. We unfortunately do use some of them in South Africa there, where there's a distribution of water, too much water in an area. But in this day and age now, we really need to try and use that water elsewhere there.
And that brings me to my next question. What is the business case for measuring water balance? So why is it important for mines and industries?
I think the business case comes down to two things. The first one is that you have to buy the water in. So the more water you need to sustain a mining operation, the more you have to buy in. So, usually when you do a feasibility study, or when you're trying to understand what you need to in order to sustain a mine, you need to find water.
So even if you've got an off-take for a river, you're paying for that.
You've got to pay for that as well there. But you will maybe only get an allocation for, say, 2 megalitres a day or something like that there. And then you perhaps don't have that in the river itself to be able to take out there. So then you need to look at your water balance and say, okay, where best can I save water so that I don't really need to use as much of that in the process itself there. And then you would look at ways to reduce your evaporation, smaller dams, lining, sometimes even filter pressing. When you look in Namibia and some of the Namibian mines, the tailings is filter pressed so that very little water goes out with the tailings.
And have you heard of in California where they're using these rubber balls to try and prevent evaporation?
Yeah.
I think there's some similar schemes in South Africa that have been.
Yes, we've tested out a few times, but I think one of the better ways that's going to happen is that some of these dams are going to have solar panels on top of them, so they're floating solar panels. So not only will they prevent evaporation there, but that sun will be used to generate some kind of electricity. And I think as time goes on, there will be more and more technologies used to try and reduce the amount of water. If you went to the mining in Indaba earlier this year, there was a lot of talk about the zero water demand from mines. So the mines will try, as part of their strategic plan, to not bring in any extra water, just use the water that they get from groundwater and from the sewerage to sustain their mining operations.
Okay, and coming back to your earlier point on technology, what are some of the main technologies used now in mines to manage their water use, and where's the future heading?
Okay, so some of the ones that are used now, I just spoke earlier about some ones in Namibia where they are using filter presses to reduce the water. So not only does that reduce the evaporation component, but also you have a dry kind of that interstitial storage, which is the water that's stored within your tailings dam, is now reduced substantially because you've pressed the water out there. So your filter press really is just squashing the tailings so that there's no water left within it before you take it out there. And the other technologies, I think, really are more to try and the more successful ones. Not successful, the ones that are the greatest rand per cube kind of around, just trying to stop the water from leaving your system through those three things that I was talking about: seepage, evaporation, and interstitial storage.
Okay, so those will probably just get better as the technology improves?
Yeah, I think so. I mean, there's always going to be problems with regards to, you can't just convert a tailings dam to now take thicker tailings there, because you have different pumps, different pipes, you have different infrastructure requirements there. But any new kind of infrastructure and new tailings dam will need to take these new technologies into account there. So when you do your feasibility study, you may say, okay, we're going to use less water, but our electricity consumption is going to go up there, or because now you're pumping water, or you're using more diesel, for instance, if you take it by truck. So there will be different problems that come with it, but in this country, with this climate, we have to do that.
Okay, and that brings me to sort of problems that one encounters in the different mines. Different commodities are associated with different contaminants. Am I right? Could you outline just the general associations for me?
Yeah. So, if you take something like the sand mining or rutile mining, their biggest contaminants are really, because it's all mechanical, so they don't add in. So they're looking really at the suspended solids there, making the water murky. Because, so that you want to make sure that doesn't get through to the environment there.
Can I ask one more while you're on the rutile and that? Don't you also get some seepage from the diesel, because there's a lot of machines, coming in and off of that site?
Yeah, you could well do that, but the only way to deal with that is operational kind of. Make sure that your vehicles are okay. Make sure that if there is a spill, that you deal with it quickly.
Can you do oily water separation, or is it?
No, very much so. You can do that.
Okay.
That's one of the easiest ones because it floats.
Okay. And then you were telling me about other commodities, sorry.
Yeah, so some of the other commodities that will have different pollutants will be something like coal, obviously have the sulfates there. Some of the gold ones here may have that acid mine drainage related stuff there. Some of the platinum mines might have sulfates and nitrates depending on how the mining or the areas that it looks at there. And so each gold could have cyanide problems there. So each one may have a different requirement there in terms of.
And now we're talking about contamination. So how does reducing water use affect contamination at different operations?
Okay, so at the moment, some of the mining in South Africa is in relatively wet areas over there. So for instance, some of the coal mines in the Moluhleni area, they've got a lot of water that comes into their system which either gets treated or released there. So if there is some kind of seepage, there unfortunately is some kind of dilution that assists with to reduce the amount of pollution that is noticed in some of these rivers itself there. But if you're in an area that's much drier and you're using less water, if you spill into the environment, in a dry environment or that doesn't have any other water, then your pollution is going to be much worse. You're going to have a lot more contaminants in the river that you discharge to, or into the groundwater resource that you discharge into. So it becomes more and more important then, I think, first of all, to make sure that you reuse the water as much as possible, so you reduce the amount of discharge from your system itself there, and that you have much better controls of collecting seepage or discharge from your facilities there, so that before it gets into the rivers or into the groundwater, you can capture it there and reuse it.
So I'm just thinking, because this video will be watched primarily by municipal engineers, I think something they'd be interested in from that municipal side is what are the sort of the penalties and risks for contamination that your municipal bylaws will sort of be in place to guard against?
Yeah, so in the municipalities there has been quite a lot of emphasis on trying to find and find the people that are polluting water there. There has been some success there, where I think in past there, I remember in the early 1990s there was some of the rivers were a different colour to what the natural water was, because dyes or something was discharged continually into these rivers.
Yeah, textile manufacturers, you'd get sort of a red river somewhere.
Yeah. So now, that just doesn't happen anymore. It's the more responsible kind of companies make sure that they don't deal with that there, and if they have a problem, they generally let the municipalities know. Clearly there's always people that are not going to follow the rules there, and that's the municipalities really do need to make sure that those are the people that are fined, kept, and ensure that they meet their regulations, meet the mining the municipal regulations.
Okay, thanks. And then a recent trend in the South African mining community has been the closing of older mines and sort of this movement and migration, and you'll see sort of new diamond mines opening up in Zimbabwe, for example.
Yeah.
So what sort of problems do you envisage with this sort of shift?
Yeah, and we live in an interesting age there, because the problems in the past, the people that started the mines in this area in Johannesburg, they had to get the water from the Vaal River, and they had a decent enough and big enough river to start up with some of their mining industry. Some of the problems that we're going to have going forward is that the areas that the mines are don't have those big water dams and don't have those big infrastructure to get water to those areas there. So the problem is going to be that, first of all, you're not going to have the infrastructure, and secondly is that that if you bring in water, you can't just bring it in for yourself there. It's got to be a kind of it's got a collaborative with the municipalities to make sure that not only are the industries met their water requirements, but they meet the water requirements, they also have to make sure that that the communities also have there. So larger quantities of water are going to be needed than just the industries. So that is one area, is that there's going to be less water available for these developments in these areas. And the second one, I think, is that, and we just briefly spoke about it earlier, is that the contamination is going to be far more severe. Wherever we go on these new mining areas, we're going to have more pristine areas that are going to be impacted on from the mines itself there. And the mining and industry fields are just going to have to make sure that whatever technologies they put in place there, that they are there to reduce the amount of pollution.
Okay, so we've discussed mining extensively. Let's move on to how municipalities deal with their water. Specifically, stormwater has been a hot topic recently. Why is stormwater control important for municipalities?
Yeah, it's another area that SRK has been hugely involved in over these last few years, and I think it's an area that, with really why you need to control stormwater on on municipalities. I love mines, obviously. Is that municipalities, as there's more and more development, the runoff from a more developed site is much more quicker and causes many more erosion related problems there. So the control of stormwater around municipalities is that your objective really should be to be able to capture your stormwater from your developed site. So for instance, if you've got a complex, you capture that water in some kind of attenuation facility, and you allow the water to slowly go out into the rivers. And that way then you reduce the amount of potential erosion that happens in the rivers itself there, and secondly then that you can ensure that there's no flooding or reduce the potential for flooding in these catchments over there. So stormwater also revolves around floodlines. Now floodlines are really there to ensure that any new development is placed outside a 50 or 100 year floodline. The Water Act requires that it's got to be outside the 100-year floodline, and that also is partly to ensure that you don't destroy the river itself there. Too many places in the early years, development was right up against rivers, and it didn't give the river any chance to be able to deal with the water. So you get these incised channels, all the embankments have eroded away, and that's because of this higher velocity water that's coming down these rivers over there.
And your attenuation facilities, are we talking reed beds and man-made wetlands? Is that the sort of infrastructure, green infrastructure, or are there other?
Yeah, so usually there's two kind of ways that you've got to deal with attenuation. The one is that it's actually got to be a dam. So you've got to really build it like a bath, and you'll see that many of these complexes have got it now. So it's really a bath, and you can imagine that the stormwater has got two taps that come on, and then you've got a small bath plug at the bottom. So the water quickly comes into the into your bath, and then slowly releases out the bottom of the dam. So that is one, and that usually, if you do it well, you can use the wetland kind of situation where the water just stays in an area that's full of flowers or something like that, and then slowly releases it out there. And then there's even more exciting ways that I think are going to happen in the future, is that the water can be stored underground and then reused back in the complex or something like that. But unfortunately, you always have to try and slowly reduce that water, so the next storm that comes, you've got enough storage space to be able to contain the water there. So there is always a balancing act in terms of storing the water versus releasing the water to the environment.
Okay, thanks. And what are the main ways municipalities have implemented stormwater reclamation?
Yeah, I think the stormwater that is collected in off roofs is one way that the municipalities could implement more, I believe. If every single house and every single property or roofs could go into some kind of JoJo tank and the water then reused, first of all you will reduce the amount of stormwater that comes off your site, and then second of all you can reuse that water. There is always a problem, is that our rainfall comes in big thunderstorms, and if your JoJo tank is full, then you don't have any other place to store the water, so the water then goes off then. So that is still an area, and I've got a system like that at home, and the only way that I believe that it works properly is if as you store the water, you use that water first before you use any other water in your from municipality related stuff there. So the quicker you use it, the more efficient your harvesting system will be.
Okay, and you get all kinds of smart technology to control that these days, don't you?
Yeah.
Yeah, and the municipalities, I think they don't provide subsidies, but that might even be something worth looking at.
In the future, yeah.
Mm. And my last question is, how do you use stormwater infrastructure to help with water harvesting?
Yeah, so some of the infrastructure that could really help there, if you think of tall buildings where you've got pillars, and those pillars could have some component of storage of water that could be used there. So you could capture the water from a roof and then use the pillar as the storage component there. And then we spoke briefly about it earlier there, permeable to make your parts of your garden permeable, so that the water that runs towards there can be stored, and you don't then have to irrigate as much as what you would normally have to do on a normal garden. But you need to do this planning up front. You can't really implement it post has been developed over there, because you don't really have the space sometimes to be able to build these things.
Okay, so again it's an interdisciplinary approach where you have architects and building contractors working with the engineers and with the municipalities to come up with a solution.
Yeah, very much so. That's I think it's the beauty of all the work that happens now, is that there's much more in engineering. There's much more of an interdisciplinary approach there, and I guess that's where places like SRK can really assist people, is that you can come to an organisation that has a lot of expertise over a lot of disciplines to help you think through these solutions.
Okay, brilliant. Thanks very much for your time today, Peter.
Thank you, Francis.
Okay, great. That was Francis Ringwood, and I'm signing off for CPD On Demand.